Okay, so now we're going to do some examples, and just so we have the formula to look at, I'm going to write it right here. So the derivative of log base b of x is equal to 1 over natural log of b times x, right? And so we're just going to use this formula to find these derivatives. So first off, we have 9 times the derivative of log base 4 of x, so we just directly apply the formula, and that will give us 1 over natural log of 4 times x, and that's the derivative, right? And then the same thing, or a very similar thing for the next one. So here we have a log base 2, so the only thing that changes is that number that's inside of the natural log. So natural log of 2 times x, right? And so if you wanted, you could rewrite this as 9 over natural log of 4x plus 12 over natural log of 2x. And you could combine these fractions, but I won't do that in this case. Okay, so moving on. So I just want to remind you that if you see a logarithm without a base on it, it's missing that, we assume that that's log base 10, right? So this is going to be 5 times log base 10 of t. So our derivative is going to be 1 over natural log of 10, and since our variable here is t, we have times t, because right, instead of x, using x as our independent variable, we're using t. And then the next one is natural log of 2t. So what we do is we have something inside of the natural log. This 2t is a function of t. It's not just t itself, so we have to use a chain rule. We start by taking the derivative of the natural log. That was the nice one that's just equal to 1 over x. So in this case, we would get the derivative of the outside function is 1 over the inside function, which was 2t, times the derivative of the inside function, and the derivative of 2t is just 2. So that's going to be our answer. And these 2's cancel, so you could rewrite this like so, and that would be your answer. And here, in this next problem, we have a similar thing going on where we have a natural log and then we have a function inside of it. So what we do is we first take the derivative of the natural log, that's 1 over x. So in this case, we'll get 1 over the entire inside of the function, and then we just multiply it by the derivative of the inside, right? So 6x plus 2, and that will be our answer. So there is a pattern going on here that you may notice, and in general, so this is something that you can use to maybe do your calculations faster, or it's just nice to keep in mind. If you have that you want to take the derivative of natural log of some function, right? So here we have to use a chain rule, right? We'll always get first 1 over f of x, and then we multiply it by f prime of x. So it's just f prime of x over f of x. And so see that I can rewrite this as 6x plus 2 and 3x squared plus 2x, and this is my f of x, and this is my f prime of x, right? Okay, and we have one more, so I'll just box this off. We have one more example here, and in this case we have to use the product rule because we have those two functions being multiplied together, and then we have another chain rule using the natural log. So first we take the derivative of t squared times the other function, and then we get t squared times the derivative of this guy, which would give us 5t to the fourth, so that's the derivative of the inside over the regular function, t to the fifth. Right, so we can actually cancel, a bunch of these would cancel, we would just be left with 5t in this term, actually, and then this one doesn't simplify. Okay, so that would be your answer. So it's just adding one more function to our library of functions that we now know the derivative of. Okay, and so next we're going to talk about logarithmic differentiation, but before we do that, I just want to review the log laws. If you're super comfortable with them, then you can skip this portion of the video, but we are going to be using these a lot in this section, so it's really good to just review this, right? So first of all, if we have log of a times b, this can turn into log of a plus log of b, right? And then also we have log of a over b, and this is equal to log of a minus log of b. So when we have a ratio, we get subtraction there. And then lastly, log of a to the n, we can pull that exponent down in front, so it goes out here, right? And we get n log of a, and then the exponent, since we moved it out front, is gone. Okay, so we actually only have 3 log laws, so these shouldn't be there. Some things that I wanted to mention were that were some common mistakes that can be made. So maybe I'll do this in a different color so it's not, so you can tell the difference. So just to beware of these, you don't get log of a plus b equals log of a plus log of b. So notice in the actual log law, the correct one, we have multiplication turns into addition between 2 logarithms. Here, all I've done is write a plus b and then log of a plus log of b. So there was no transformation from multiplication to addition. It was just addition on the one side and then addition on the other side, and that's not correct. Right, so that's the first one. Maybe I'll use a bullet. Also, it doesn't go in this direction. So I said that multiplication turns into addition. So multiplication inside of the log turns into addition outside. It doesn't go the other way. So addition inside of the log does not turn into log a times log b. Right? Okay. And then also, if you had, so this one's easier to demonstrate with an example. So an example, incorrect example, would be log of 2x squared, and seeing that exponent, just taking it out front, right? So this is not equal to 2 log 2x, right? And the reason is that when we have this exponent here and we apply this log law, it's being applied to, or not, it's being applied to, but this exponent is on the entire inside of the log, so on that entire thing, a. So before we apply the law, we actually need to make sure that the exponent is attached to the entire thing and then apply the log law. So for example, so if we were to correct this, it would be log of 2x squared. We would rewrite this as, if we wanted to rewrite this as something, the whole thing to the power 2, we would have to write 2 as square root 2 x, and then that thing squared would be equal to this. So these two things would be equal. And what I've done is rewrite this so that, in fact, maybe we can drop these parentheses so it's a little bit easier to see. Root 2x to the power 2, right? And then since it's being the entire thing right here inside of the log has the exponent 2, we can move that out front. So 2 log of root 2x. Okay, so just make sure you first have it in this form before you apply the log law. Okay, and next we're going to talk about implicit differentiation.